Hello everyone, this is Samantha Islam from University of Cambridge. Today I'm going to present on selection criteria for planning cold food chain traceability technology enabling Industry 4.0. In this work, my co-authors include my supervisor, Dr. Jonathan M. Cullen from Cambridge Engineering, and also our collaborator, Professor Louis Manning from Royal Agricultural University. Cold food chain is a low-temperature controlled supply chain that carries perishable food items that require systematic operations and temperature management to prevent the excessive ripening, dehydration, softening, color or texture changes, and growth of pathogens in the product to maintain their shelf life and marketability. Food traceability is a popular concept nowadays in food supply chain management that involves identification of the traceable resource unit that can be a production batch or the trade unit or logistics unit. When the different operations are performed on the product and the product's quality or different intrinsic properties changes, data are also being recorded on these operations and the properties of the product, and the data is linked to the product through their TRU identification number, and when the product moves to the next supply chain stage, the data or a part of data is shared to that link, and that continues until the product goes to the customer. Therefore, customers and other stakeholders of the supply chain can access the data. Traceability system is implemented through information system and various technologies that can enable perfect inventory counting, real-time monitoring, communication of history and quality parameters of the product, and also shelf life-based distribution of the perishable items. Industry 4.0 driven traceability can be marked by the replacement of paper-based recording with extensive use of auto ID technologies and sensor technologies that can help with less human intervention, higher data carrying capacity, faster reading speed, accuracy, real-time product safety, and quality monitoring. For Industry 4.0 transformation, it is important to have an appropriate technology planning approach that can optimize between the cost and benefit criteria of different technology alternatives, and that also need to match a specific cold chain scenario requirement or scenario imposed constraints. So the overall technology selection requires a systematic approach. Therefore, this study contributes to the existing literature by combining all the traceability technology criteria enabling Industry 4.0 transformation. We have considered 17 criteria for cold food chain management that include identification and temperature monitoring perspective. We have considered 16 generic technology solutions available throughout the market, so not any specific technology from any specific company. We have constructed a quantitative technology performance matrix by transforming our technology data collected from different sources. The limitation that we have in this study is we have not considered the communication or data integration technology such as blockchain, which is a breakthrough technology for traceability system. Therefore, we have planned to consider it in our future endeavor. For methodological approach, we have used an iterative literature search of various academic studies, tech company reports, data sheets, and web pages. We have explored e-commerce websites such as Amazon and Alibaba. We have interviewed experts from Emerson and Siemens tech companies. Finally, we have used a fuzzy approximation of our gathered technology information to transform it into a quantitative technology performance matrix that can be further used in different technology selection approach. We have considered total 16 technologies that includes different types of barcodes, RFID, in low frequency, high frequency, and ultra high frequency range with read-write and read-only capacity. We have also considered semi-passive and active RFIDs, and RFID with sensor capacity. Apart from that, we have also considered the wireless sensor and time temperature indicator technologies. We have considered 17 different criteria that include cost effectiveness, waterproof capacity, flexibility, accuracy, and all other different criteria. The highest cost-effective technology is barcode with 10 to 25% media saving in comparison to paper. We have also found that the ultra-high frequency RFID tag are cheaper from their high frequency and low frequency counterpart. However, the ultra-high frequency reader is much more expensive than high frequency and low frequency reader. Waterproof capacity is highly important for cold food chain monitoring, and we have found that the low frequency, high frequency active RFID, wireless sensor, and time temperature indicator comes up with waterproof capacity. However, the semi-passive and passive RFIDs, which work in ultra high frequency range, are susceptible to water. Flexibility means where the data carrier is printable, lightweight, or wearable, and this capacity is provided by barcode because they can be printed in any medium, whereas active RFID and WSN do not offer very high amount of flexibility because they comes up with heavy components. The lowest accurate data carrying technique is manual paper form because that involves a huge amount of human intervention. The highest accuracy providing technologies are NFC and all types of RFIDs. Barcode accuracy can be as low as 80% due to its line of sight and requirement on human intervention. The wireless sensors and time temperature indicator can provide accuracy with 5 degrees Celsius deviation in its temperature data. In terms of reading range, barcode requires line of sight and close contact reading. Low frequency RFID also require close contact reading, but all other RFID and wireless sensors provide contactless reading. These criteria is not applicable in paper form and time temperature indicator because they require manual operation. Paper form and time temperature indicator involves the slowest data transfer speed because they require manual operation, whereas active RFID provides the highest data transfer speed. High frequency and ultra high frequency RFID provides between 100 to 650 kbps data speed, whereas wireless sensor provides around 250 kbps data transfer speed. Multi-tag readability require anti-collision algorithms that comes up with high frequency, ultra high frequency, semi-passive active RFID and NFCs. These capabilities not available for paper form or barcode. In terms of identification capacities, all types of RFID can provide until item level identification. 1D barcode can only provide product level identification or SKU level identification. Tag writing cycle means the memory reprogramming capability. Read-only RFID do not provide any writing capacity for the user. Barcode can provide single writing cycle, and read-write RFID and NFC can be written multiple times by the user, and that means the user can edit or add extra or additional product parameters inside the data carrier's memory. Memory capacity can be increased in read-write RFID, however they also require high price and requires high data transfer speed. Environmental parameters recording is highly important for cold chain monitoring. Time temperature history record is possible with time temperature indicator, semi-passive and active RFID with their onboard batteries. However, the high frequency, ultra high frequency RFIDs and wireless sensor technologies only offer discrete recording. Real-time location recording is possible with active and semi-passive RFID with their onboard GPS module, and so is also offered by the wireless sensor technologies. Real-time alert is important for identifying inequality-related issues in the perishable food items. Active, semi-passive RFID, wireless sensors can all provide real-time alert. And this capability is also available with time temperature indicator as they provide the electric or colorimetric signal in response to inequality-related problem. In terms of data carrier durability, passive RFID tags are highly durable, like 10 to 20 years. Active and semi-passive RFID can only last for 2 to 7 years, considering their short-lived battery life. And manual paper form and barcodes are highly vulnerable to harsh environment, therefore they are not highly durable. Worldwide standard is available for barcode, RFID, NFC, wireless sensor network. Manual paper form and time temperature indicator do not have any standard. Data security is an important criteria when the product goes through third party. Barcode have simple encryption, whereas RFID can provide security with deeper encryption, password protection, and cryptographic protection. Manual hardware requirements for readability is important criteria when there is a lack of electricity, or where the operator needs to read the data immediately without any reader, or where there is limited reading capacity. Paper form and time temperature indicator do not require any reader, whereas QR code and NFC code can be read through smartphone applications. We have converted our gathered data into a technology performance matrix with fuzzy approximation. The matrix can show the comparison between different technologies along different criteria. This matrix can be used further into any technology selection methodology. To demonstrate the use of the technology performance matrix, we have used two case studies. In the first case, some cold food chain actor aims to monitor real-time temperature of fresh salmon that is palleted and transported by road and air between countries. Throughout this journey, the product goes through different temperature that influences their shelf life. We have chosen 9 criteria from the criteria list we have discussed in this paper. For this work, environmental parameters recording is highly important criteria because the CFC actor want to monitor the temperature itself. We have considered identification capacity because that is required for identifying the salmon pallet or the products inside the pallet. We have considered worldwide standard because the product is transferred between 2 countries. If there is standard, then supply chain actor from different country will be able to understand that and analyze the data. We have also considered data security because the product is transported with third party, so security is highly important. We have also considered additional parameters such as accuracy, data transfer speed, tag writing cycle, reading range, and memory capacity. We have used a simple weighted sum method, applying the data from the performance matrix, and by summing up the score for different technologies, we have found that active RFID is the highest performing technology for this case study. Therefore, active RFID can be chosen for this scenario. We have used a similar approach for a second case where a consumer wants to trace the sustainability information such as energy consumption or carbon footprint that have been recorded throughout the supply chain of a cheese portion she buys from a store. However, she wants to use her smartphone to read the data. Therefore, data carrier has to be lightweight, has to be less expensive because the cheese portion is a small trade unit, can be considered as a low value item, and it has to be flexible enough, and it has to provide less reader requirement. So we have considered some criteria that we we think is relevant for these cases. And using the same simple weighted sum method, we have found that 2D barcode or QR code is the highest scoring technology for this case study. So similar approach can be used for different supply chain case study, and more sophisticated algorithm can be developed by using the metrics. That's all for today. Thank you for your kind attention.